The worm wheel shall be made from this piece of aluminium scrap. It shall be a 60-tooth module 1-spur gear, like this plastic one I made. It will not be a true worm wheel, but hey, I'm building an indexer, not a winch. The blank is bored with a hole saw. And the extra bits cut off. I have a dedicated arbor when making gears, but this one has an odd-sized bore. So I am making an adapter out of some hardwood. It shall be pressed onto this arbor. A shoulder is turned to the diameter of the hole left by the hole saw. The blank shall be pressed onto it. The blank outside diameter shall be turned down 1 mm oversize and faced. The previous operation produced two reference surfaces which are placed in contact with the chuck jaws. This allows the other side of the blank to be faced, making it parallel to the other face. The bore is taken to its final dimension, that of the shaft diameter. The bore also results perpendicular to the sides. That's a nice fit. A shoulder is turned on the wood adapter equal to the inner diameter of the gear blank. The gear is pressed onto the adapter. The gear blank is turned to 62 mm, module 1 gear diameters are 2 plus the number of teeth. This is a small indexer I made from a discarded clapped-out 16 mm drill chuck. The chuck is from a good brand, and despite the abuse it experienced, it has negligible runout. On its own, this tool can perform basic indexing. It is primarily intended to be held in the mill vise, like so, but it can also be angled. The dividing kit I fitted to the lathe can also be fitted to it, turning it into a dividing head. The dividing kit is fitted to the indexer. I built it so I could use my lathe change gears. The worm gear carrier is adjustable to fit the different sizes. That's a 60-tooth one I made. So to cut a 60-tooth gear I need a full rotation for each tooth. The arbor with the gear blank was transferred from the lathe to the dividing head. The indexer can be locked to operate the chuck and during machining. Since this poor chuck has had its teeth knocked out, I made this post spanner to be able to tighten it. I use a ruler to set the top of the gear cutter at the same height as the top of the blank before zeroing the x-axis diaro. To set the cutter on the center of the blank, I lower it by a distance equal to the blank radius minus half the cutter width. And visually double check that I am actually on center. I then set the cutter to touch the gear blank and zero the y-axis diaro. I move the cutter away along the x-axis. Before setting the cut along the y-axis, The depth of cut for a Module 1 gear is 2.25 millimeters. Here we go. Each tooth is cut in one pass. The mill is set at its lowest speed and the cutter fed slowly. I need to be careful to clear the cutter before indexing the gear. The indexer is unlocked and the blank is indexed to cut the next tooth. Tooth number 1 done, 59 more to go. And the gear is cut. I had a blonde moment and forgot to cut the key slot before cutting the gear teeth. I hold the gear with some plastic and use the edge finder to locate the center of the bore. After finding the first edge, I zero the DRO and note the reading at the other end. I then set the mill on half this reading. An end mill is used to cut the key slot. And there you go, the gears mesh perfectly. One can say it took more time to make the blank than to cut the teeth.